There are moments in history when humanity builds something that changes the way we see the universe forever. The launch of the James Webb Space Telescope was one of those moments. It was not just another space mission. It became a new pair of eyes, capable of looking farther into the cosmos than ever before. From the day it left Earth to the discoveries made by July 2026, this remarkable observatory transformed countless questions into astonishing answers while creating even greater mysteries waiting to be explored. For generations, people looked at the night sky with wonder, imagining what existed beyond the stars. Every new telescope brought us closer to understanding our place in the universe. But many regions remained hidden behind clouds of dust and immense distances. Then came a telescope designed to observe the universe in infrared light, allowing it to see through cosmic dust and detect some of the faintest and oldest objects ever discovered. The journey itself was extraordinary. After launch, the telescope traveled nearly 1.5 million kilometers from Earth to its operating position. Every stage had to unfold perfectly. Its massive golden mirror, made of carefully engineered segments, expanded in space with incredible precision. A tennis court-sized sun shield unfolded layer by layer, protecting the sensitive instruments from the sun's heat and allowing them to cool to temperatures colder than almost anywhere naturally found on Earth. Many believed the most difficult part was building the telescope. In reality, the greatest challenge was making sure everything worked flawlessly millions of kilometers away, where astronauts could not repair it. Every successful deployment became another historic achievement in engineering. Once fully operational, the telescope immediately began producing images unlike anything humanity had ever seen. Ancient galaxies appeared in breathtaking detail. Some of the light reaching its mirrors had traveled for more. A historic launch that changed astronomy. The James Webb Space Telescope's successful launch, complex deployment, and revolutionary technology opened a new era of deep space exploration. The launch of the James Webb Space Telescope marked one of the most significant milestones in the history of space exploration. It was far more than the beginning of another mission. It represented decades of innovation, international cooperation, and scientific ambition. Designed to observe the universe in ways that were never before possible, the telescope carried advanced infrared instruments capable of detecting faint light from distant galaxies, newborn stars, and faraway planets. After leaving Earth, it traveled nearly 1.5 million kilometers to its destination, where every step of its deployment had to succeed perfectly. Its giant golden mirror unfolded segment by segment, while its enormous sun shield expanded with remarkable precision to protect the sensitive instruments from heat and light. The entire process was so complex that even a small mistake could have ended the mission before scientific observations began. When everything worked exactly as planned, it became a historic engineering achievement celebrated around the world. Once fully operational, the telescope immediately demonstrated its extraordinary capabilities by delivering breathtaking images and valuable scientific data. It proved that years of careful planning, testing, and determination could overcome enormous technical challenges. The successful launch and flawless deployment did more than place a telescope in space. They opened a completely new window into the universe, allowing scientists to explore regions of space that had remained hidden for billions of years and setting the stage for discoveries that continue to reshape modern astronomy. Looking back to the beginning of the universe, Webb captured light from some of the earliest galaxies, allowing scientists to study the universe as it existed over 13 billion years ago and rethink theories about galaxy formation. One of the James Webb Space Telescope's greatest achievements has been its ability to look farther into the universe than any previous space observatory. Because light from extremely distant galaxies takes billions of years to reach Earth, observing these objects is like looking back in time. Webb has captured images of galaxies whose light began its journey more than 13 billion years ago, revealing what the universe looked like shortly after the Big Bang. These observations have provided scientists with an unprecedented opportunity to study the earliest stages of cosmic history. Instead of finding only small, young galaxies, Webb discovered that some early galaxies appeared larger, brighter, and more developed than many existing theories had predicted. These surprising findings encourage astronomers to re-examine long-held ideas about how quickly galaxies formed and evolved during the universe's infancy. Every new observation has added valuable pieces to the puzzle of cosmic evolution, while raising new questions that continue to inspire scientific research. Webb's exceptional sensitivity also allows it to detect incredibly faint objects that were invisible to earlier telescopes, expanding humanity's view of the observable universe. By revealing ancient structures with extraordinary clarity, the telescope has transformed our understanding of the cosmos and demonstrated that the universe still holds countless mysteries waiting to be explored. Rather than providing all the answers, these discoveries have opened exciting new paths for future research, reminding us that every breakthrough in science often leads to even greater questions about the origins and evolution of everything around us, revealing the hidden birthplaces of stars and planets. Using infrared vision, Webb looked through cosmic dust to observe newborn stars, planetary systems forming, and a life cycle of stars in incredible detail. The James Webb Space Telescope has completely transformed our understanding of how stars and planets are born. For centuries, many regions of space remained hidden because thick clouds of gas and dust blocked visible light from reaching traditional telescopes. Webb's powerful infrared technology changed this by allowing scientists to see through these cosmic barriers and observe the hidden processes taking place deep inside star-forming regions. The telescope revealed breathtaking details of enormous clouds where new stars are emerging, showing the complex structures and movements that shape the creation of future solar systems. These observations provide important clues about how stars develop, how planets begin forming around them, and how the ingredients necessary for life are distributed throughout the universe. Webb has also studied young planetary systems surrounded by disks of dust and gas, capturing moments similar to what may have occurred when our own solar system was forming billions of years ago. By examining these distant environments, scientists can better understand the origins of planets, including Earth. The discoveries made by Webb have shown that space is not a quiet, empty place, but a constantly changing environment filled with creation, transformation, and evolution. Each image of a newborn star or a developing planetary system offers a glimpse into the powerful natural processes that have shaped the universe from its earliest moments to the present day. Searching for signs of life beyond Earth, Webb analyzed the atmospheres of distant exoplanets, detecting molecules like water vapor, carbon dioxide, and methane that help scientists evaluate their potential habitability. One of the most exciting achievements of the James Webb Space Telescope has been its ability to study the atmospheres of planets orbiting distant stars, known as exoplanets. Before Webb, scientists could detect many of these worlds, but learning what their atmospheres were made of was much more difficult. Using its advanced infrared instruments, Webb analyzes the tiny amount of starlight that passes through a planet's atmosphere during a transit. This light carries valuable information about the gases surrounding the planet, allowing researchers to identify molecules such as water vapor, carbon dioxide, methane, and other chemical compounds. These discoveries provide important clues about the planet's temperature, weather, atmospheric composition, and overall environment. While finding these molecules does not prove that life exists, it helps scientists determine whether a planet may have conditions that could support life as we know it. Webb has also observed a wide variety of exoplanets, including hot gas giants, rocky worlds, and planets unlike any found in our own solar system. By comparing these distant worlds, researchers are gaining a deeper understanding of how planetary systems form and evolve. Every observation expands our knowledge of the incredible diversity of planets throughout the galaxy. As technology and research continue to advance, the James Webb Space Telescope is bringing humanity closer than ever to answering one of the greatest questions in science. Are we alone in the universe, or is life possible beyond Earth? Transforming our understanding of space by July 2026. By July 2026, Webb had produced thousands of groundbreaking observations, challenged existing scientific theories, inspired new discoveries, and fundamentally changed humanity's view of the universe. By July 2026, the James Webb Space Telescope had firmly established itself as one of the most influential scientific instruments ever built. Since becoming fully operational, it has completed thousands of observations, producing an extraordinary stream of data that has reshaped modern astronomy. Webb has explored the earliest galaxies, investigated the birth of stars, examined the atmospheres of distant exoplanets, and revealed intricate details of planets, moons, and other objects within our own solar system. Each new observation has expanded humanity's understanding of the universe, while also raising fresh scientific questions. Rather than simply confirming existing theories, many of Webb's discoveries have challenged long-standing ideas about how galaxies formed, how quickly the early universe evolved, and how planetary systems develop over time. This has encouraged scientists to refine models, conduct new research, and explore possibilities that were once considered unlikely. Beyond the scientific community, Webb's breathtaking images have inspired millions of people around the world, reminding us of the beauty and scale of the cosmos. The telescope has strengthened international collaboration, with researchers from many countries working together to interpret its discoveries and share knowledge. As its mission continues, every new image and measurement has the potential to reveal something unexpected. By July 2026, Webb had not only transformed our understanding of space, but had also sparked a new era of exploration, inspiring future generations to continue searching for answers about the origins, evolution, and future of the universe.